Welcome back to our lecture series on automated machine learning. Now we talk about why we actually need automated machine learning, what can it do for us. So let's directly dive into it. Here's a definition of automated machine learning which tries to summarize it actually as much as possible. So we're saying automated machine learning contributes to the efficient, reproducible, and systematic design of effective intelligent systems by creating a general automated development process targeting the full machine learning workflow. So I would like to highlight, so it's somehow about efficiency, about reproducibility, and being systematic in a sense. And that we would like with doing that to come up with an automated development process, which should be generous not only for single data sets, but maybe for many and for many different tasks. And we're doing all of that in the end to address the entire full machine learning workflow. Although I have to admit, parts of automated machine learning, of course, also only address parts of that kind of workflow. But we can do it even for the full one. So why are we doing that? Why would I recommend to you to use automated machine learning? So first of all, it improves efficiency and effectiveness, as shown in many already competition and comparisons and studies that automated machine learning can compete or even outperform human developers on these little nitty-gritty details. They have to adjust things where you don't know how to stuff. Of course, humans can leverage quite a bit and very successful their own expertise and what they did in the past. But in general, if they're confronted with a new problem, they're always starting, nevertheless, fairly from scratch. Furthermore, humans tend to be fairly biased and maybe doing very unsystematic evaluations. Automated machine learning, depending on the approach, of course, does it in a far more systematic way, which can help you then being more efficient, or it can also help you with being more reproducible. You can run software over and over again, such as an AutoML system, but you can't run the human with the same state over and over again. And if you're thinking about legal regulations these days, reproducibility, documentation, all of that becomes more and more important. And of course, from a scientific point of view, you would like to have reproducibility anyway. This has led to broader use of machine learning models, so it means faster development cycles, that we are more faster, for example, to come up with a prototype. We require less machine learning expertise to actually do projects. We can so go far beyond, for example, computer scientists. We can include more people. We can act more on its own to develop very nice machine learning and AI applications. Here's one glimpse of one of the success stories of automated machine learning in terms, for example, of efficiency, what I mentioned before. So AutoML is maybe one of the most famous AutoML systems these days, and it won top 3 positions in 7 out of 21 tabular competitions on the platform Kaggle. And Kaggle is one of the biggest platforms actually to run machine learning, data science competitions, and each of the competitions had on average 1,500 human teams involved, right? So if you then say, okay, an AutoML system can be in top 3 of that, 8 competitions, as you can see, even won directly. That shows the potential and the power of these systems where you can say, okay, here's my data set. I press a button. I would like to get the best machine learning system. And of course, these kind of systems are now used also as an industry standard. NVIDIA, Intel, Capcom, Mitsubishi, Oracle, Pinterest, and others are already using these kind of AutoML packages such as AutoML. Very important to highlight this kind of idea why we need to do it in a systematic way. So we have different kind of approaches, and more or less underlying to all AutoML systems to one or the other way is some kind of optimization. Here only one perspective on it. If you're thinking about, for example, optimizing hyperparameters, people often tend to use grid search. And you can already say that grid search is a very, very basic way of doing automated machine learning because you don't have to decide what is the hyperparameter for your model setting, but grid search is more as doing the sweep over all possible combinations you defined and then deciding what's the best one. But you can also use random search. we discussed later on, comparison between these two, it's unstructured, but it's nevertheless systematic because it has a way of doing that. And if you set the random number generator accordingly, you can also repeat that, reproduce things, right? It sounds unsystematic, but actually even random search has a system to it, which is random sampling. A trade-off more between exploration, exploitations, and coord-Bayesian optimization. So it can also focus more, for example, on promising areas. And this is all in contrast to these unreproducible human bias, which could lead to sub-optimization, because humans tend to being overconfident in their own experience. For example, humans tend to say, I have learned about transformers in my lectures or previous projects, so I'm trying only transformers because I believe they are the best option, without maybe ever really trying out different approaches. AutoML can help you with that, being far more broad in a sense and more open-minded and less being biased. Reproducibility, I already mentioned that, is getting more and more important because systems are, first of all, more reproducible than humans. And second, the UE Act requires something like documentation, what was running when and what. And here AutoML can help you with all of these kind of things. And again, from the research scientific perspective, also research conferences and journals highly value reproducibility. So there are many reasons for why using automated machine learning also with that respect. And the nice thing is that we have seen by now more than a decade of automated machine learning research that people started to use it for different kind of approaches. So for their tasks from different kind of domains, so not computer scientists anymore. So what we're seeing here, that in psychology people used it. You see it for controlling concrete, so Morse construction. Carbonate formations, and underground hydrogen storage applications. So, and you can find many, many more of these examples. That's where people more use techniques from AutoML, maybe not full AutoML, but started already using parts of it to get better results and showing what can be done and how to leverage these kind of potential from AutoML to get further applications with machine learning and AI running. So as a summary of this video, AutoML is a key ingredient for developing new machine learning applications that like to be efficient and maybe even lack some kind of machine learning expertise. Nevertheless, these kind of MOOC here, this kind of online courses, assumes that you have a certain kind of expertise and that would like to leverage that to become more efficient and developing your new machine learning applications. It improves, so automated machine learning improves efficiency and effectiveness, but also helps in satisfying legal applications or expectations from the academic community. Therefore, AutoML is important for both machine learning developers and domain experts from other fields, and I hope I showed you some first ideas on why that's the case and how to use it. So with that, I hope I see you again in the upcoming videos. Bye.